All right, guys, so we've made it over here to Monroe, Ohio. I'm here with Dave Ruben. He is one of the owners of Mill Mechanical.
That's right.
They do all sorts of very large, heavy machining here, also large weldments and fabrication. Kind of provide services for the steel mill industry, correct?
That's right, yeah.
Yep, so we wanted to stop by. He just picked up one of the a new Eutectic Pterodyne thermal flame spray system, and he had asked if I could stop by here and kind of give him a crash course, I guess, on
oh, it's definitely gonna be a crash course
on how to use it. So we were in the area, we were driving by, so we took the opportunity to stop here and hang out with Dave. I'm excited to see their business here. I know it's going to be awesome. They're going to have a lot of cool equipment and machinery here to see, and also get to do a little spray welding with them. So let's go on in there and check it out.
All right,
we haven't seen it yet, so we're ready to do this. Dave's going to go ahead and give us a tour of the shop. This is the big fab shop right here. They do some really large weldments in here.
Yeah.
He's got this one piece up here that they're working on right now that he was explaining to me how it works, and it's a big boy weldment.
Yep. Hey guys, so this is Mill Mechanical's fab shop. We kind of get into a little bit of everything here, mostly big stuff. We cater to the steel mill industry for the most part. Kind of have a variety of different projects going on at the moment. Effectively, we're a job shop. We just do one-offs, two-offs, three-offs of big stuff for the most part. We're doing this big truss beam right now. This is the second one we've done. So it's kind of a work in progress. We've got two 40-foot, shoot, I don't even remember the size of the beam. They are pretty heavy. For the fixturing, and we capture this whole thing between two 80-footers, and that really does the trick to hold this thing straight, flat.
And you were explaining that these guys, these are just your fixture tables.
Yeah.
These large I-beams.
Yep. We've got two 40-footer, with basically four 40-footers, two sets, and we'll capture this whole weldment with the second set when it comes time to weld it out. About a year or so ago, I posted a video of the first one we did, kind of on this big rotisserie style ring setup, and we're going to do a similar thing with it this time as well, just to really be able to easily get to all the welds, because we got to get inside everything, and this is half-inch weld everywhere.
Wow.
So it's just a lot of heat all at once. If you just hit one area, that's easily accessible. That's why we put it on that rotisserie, so we spin it and get to all areas really easily. It worked out really well last time, so hopefully it works out this time.
I'm sure it will. You handled it. So the top piece is a large piece of channel. So you got flat bar welded in there.
Right, and there's, a big air line goes through this cavity.
Yeah, you're using dual shield flux core? Or is that?
For the setup, we're using dual shield flux core. For the final weld out, we're going to use metal core wire.
Okay.
With 90-10 spray.
I-beam, channel iron.
We get to, because of the setup, because of the rotisserie, we can put every weld in position, which is pretty helpful for us. I prefer to use metal core if I can. It's kind of it's a finicky wire, it has to be in position. So if we were just to weld it like it is now, we would just use flux core, but because we could flip it around, put it where we want it, metal core is the ticket. It works out well.
Looks great.
Yes, there's that. You just kind of look around. There's a variety of different things going on.
Different projects. Looks
different
like you
projects.
got another job going on over there. Is that a piece of steel plate over there?
That table, that's a slab. Yeah,
that's a slab of steel.
That's a slab of steel. That's 8 inches thick, 5 feet wide, 15 feet long.
I gotta go check that out.
That table is 28,000 pounds.
No kidding.
Yeah.
That's a proper work table right there.
I'd say so.
That is cool.
The original plan was to drill and tap a big grid in it. We just got super busy when that thing was up on the machine, so we had to pull it out. And I got impatient, so I said, "The hell with it. Let's just take it as it is."
It's just a big weld table now.
It's just a giant weld table.
That is cool. I got to get a picture with that, because you don't see that very often.
This is the tank roll that we'll have one of the rings for this guy sitting on that'll drive it. The first time we did it, we used the crane to flip it around, which of course tied the crane up. But we've got figured out to where this will be our drive, and we've got 3 idlers.
Okay.
So push of a button, we'll be able to spin this whole thing. I think this is about all assembled in the ball, a little over 20,000 pounds. And then, so we'll have that sitting on the positioner and just be able to spin it around pretty easily.
Yeah. Looks like you got the bandsaw set up over there.
Yep, yep. That was the one tool, the bandsaw and one of the overhead cranes was all that was in this room 3 years ago when we opened up the fab shop. Since we've filled it out pretty well.
Okay.
Built whatever we need, filled it with machines and an awesome crew. This table used to be certified until I got it.
You got a lot of tapped holes, so you can use it as a fixture,
Yeah.
as a fixture plate.
Exactly. I mean, that's what we wanted to do to that table, but it didn't happen. One day.
Get you a flex arm in here.
Well, we've got one next door.
Oh, you do? Okay.
We do, a big one, yeah.
Yeah, look at this right here, man. This is so cool. So it's 8-inch.
Yep. 5 by 15, 8-inch thick. I might have missed, I think it's 22. I think the slab after it was finished was 22,000 pounds, and then the base. We took quite a bit off of it.
Y'all milled the top of it? Is that what you did?
Both sides.
Oh, okay. You can see the flame cut here. Yeah. That's pretty cool. Very cool. I got to get a picture with this for Instagram.
Sure. That ultimately becomes round.
Okay.
So we've built several of these assemblies. The last 2 we built and this one that we're going to build, rather than like laying it out the actual radius on the part, we just take it, tack it off to that, build a little armature, the plasma cutter, and just hit go.
Okay.
And it just makes a perfect circle.
Okay,
it worked
cool.
out so well.
Yeah,
Saved a ton of time, virtually no cleanup at the other end of it. Where the first time we were trying to just freehand it, it was a bit of a mess. But it worked out really well with this thing.
So now we're going to go into the machine shop.
Yeah, so this is the other 2/3 of the business. The first portion of this building will be the machine shop, and then the back half of the building is the rebuild shop.
Okay. So they do machining services, any kind of machine work you need as far as job shop goes, but Dave was telling me they also do gearbox rebuilds as well. It's got that smell. Smells like a machine shop.
Smells like a machine shop.
Yep.
So this has been this whole building, this whole part of the business has been a slow, evolving work in progress. We're now getting to we figured out what we want to be when we grow up. We've got some pretty good machines in here, some new stuff, some used stuff, but for the type of work we do, we could pretty much hit all points.
Okay. I know you got some big stuff in here.
Yeah, this division wide we purchased it new. It's been an absolute workhorse. This thing it's so fast and efficient. It's been a great addition.
Is that a large, like a gantry mill?
Mm-hmm.
Is that okay? That's what it looked like. I know I see a DeVlay over here, jig mill, CNCs, some CNC lathes.
A couple ProTrack CNC lathes. This Haas is the newest edition.
Okay.
Walk over, check it out. This is what we'll be playing with for spray weld.
Okay.
That's our donor.
You might have to do the operating then. I don't know if I can run this.
Well, I'm definitely not your guy, but we'll have someone help out for sure.
ProtoTrack. This is something I've got a lot of interest in actually, the ProtoTrack lathe. Yeah, that's what you said these guys are over here?
Yep.
Got the ProtoTracks,
yep.
Okay.
Yeah, they're just a little bit bigger. There's 2 of them over there. This is the smaller one for a little smaller parts.
Okay.
We just got this.
Sterling drill grinder right here. There's a bunch of parts. Looks like they've been machining.
Yep. Yeah, those are all finished. This is the newest acquisition here. We just got this guy. Pretty heavy lathe. It can't excuse me. Can't do real long parts, but it can spin some pretty heavy stuff really fast.
Yeah, okay. These some parts that you've machined in this?
No, this isn't even set up yet.
Oh, okay.
We literally just got this last week.
You also got a Trek mill there. That's one of those bed mills.
Mm-hmm. These parts, I believe, came out of the Haas.
Okay, this stuff here.
Yeah, before it got welded on. Actually, that's all stepped around. I'm not sure what that came out of. That probably came out of division wide.
Looks great, man. Oh, here's the flex arm.
Yeah, this is the big boy. This will do. I'm pretty sure this will do up to 1.5 inches.
I was thinking this was going to be the 1.5 inch model.
Yeah, this thing is a freaking monster. And I mean, it.
How do you like it?
You just push and go. It's unreal. I have used it. I've just played with it. I haven't done any real parts with it. But I mean, it just takes off. You don't even really have to hold it.
It's effortless tapping.
Effortless.
It really does make what can be an aggravating and labor-reduced job.
Sure.
Tapping something very simple.
Yeah.
Especially
right
for
now.
manual guys, or you're doing a knot where you want to drill a bunch of holes and then you want to tap them quickly. Just come over here and fixture it, whether it be a vise or on the table.
Well, what's kind of neat about these, I'm sure you've experienced with other
You've got it locked.
previous designs that aren't necessarily like the flex arm. They work really well, but what the drive system is kind of what is the Achilles heel. This thing, I mean, if you let it, it would go through the table. I mean,
yeah.
You can't stop it. It's unbelievable. Big hole, small hole. The drive RPM is practically the same. I've never seen this thing bogged down. I've seen guys tap some pretty big parts.
Did you happen to see when I used a 2-inch tap on mine?
Yeah.
2-inch tap, it didn't act like it was struggling at all.
No.
Even when I bottomed it out to clutch it out, man, it was just, bam, it was there.
It just eats right through.
I mean, I really think that we could up the ante on that and go to a much larger tap than we do, but to be safe, you know, they've got it limited to 2-inch.
Right, with the clutches.
Yes. Very cool.
Here's the, you know, this is where the bigger machines are.
Oh yeah, yeah. Big jig mill, the DeVlay.
There's our Zaire. That'll cover, I think, 32 feet.
That's another big mill. That is cool.
The DeVlay will do 12, I believe.
What's the lathe here?
It's really big and blue.
It looks that way.
This is Big American. This is actually a pretty cool deal. We got this thing. It was used.
It is an American.
And it wasn't set. Well, let me back up. As it's explained to me, because I don't know a whole lot about it. It was only set up for like a fraction of its capability. Whoever had it prior to us made one off or whatever it was. So the thing could only do so much when we got it.
Yeah.
Well, the guys took it, basically went through the whole thing, turned it CNC, and got it pretty much up to 100%. So there's like no limit to what this thing can do. It's a beast. We do a lot of disc rolls and a lot of big drive rolls. So they'll have, you know, 4,000, 5,000, 6,000 pound rolls in this thing, and it just eats through it. The chips it throws off, man, it's unreal.
I believe it.
It just chows through stuff.
The American pacemaker I ran, it was a beast.
Yeah.
I mean, I was taking a 1/2 inch off pass easy.
Really?
It was really handling it well. And I imagine this one could handle a whole lot more than what I did on that 20-inch that I used to run. But that's cool seeing it CNC.
Yeah. I mean,
I don't even see hand wheels on here at all.
It was a challenge. The guys had their hands full doing it.
Yeah.
Because the controls were set up kind of goofy that came with it.
Yeah.
But I mean, it was like 3 mad scientists around this thing with all the covers off wide open. But they got it, man. They're real satisfied with the way it performs.
That is cool.
This was actually, funny story, this is how we met. This machine here is why I reached out to you originally about 1.5 years ago. because the ways on this thing there's some bad spots in it. And,
Okay.
I contacted actually Roy, asking him if he knew of a good contact for you.
Yeah.
So that's when I reached out to you, and we went literally around the country because your recommendation, I think, put me in Wisconsin or something.
Okay.
And then came back to Illinois, like Florida, Wisconsin, Illinois, Ohio. And then I got to make another phone call.
There you go.
But really, for what we do, this machine, it's in pretty good shape.
This is the type of machine that I really needed at Motion when I was there for some of the big mill work that we were doing. So it looks like they're just milling. They've got these weldments, these plate steel that they
our
welded
pleasure,
on.
man. I mean, no
it looks like
worries
they're
at all.
decking these surfaces off right here. We'll get a little closer look at his big gantry mill here.
Great. It's like built-in advertisement. I love it.
Since nobody's running it, I guess we could step up here and take a closer look at it. 8-inch. I believe that's the 8-inch Kurtz he's got on here. A lot of capacity right here. So this is a good look at most of the machine shop area here. We're going to go on down here to the rebuild area.
So this is the other half, or other third, I should say, of the business. This is all kind of where we rebuild stuff. And it's a crapshoot, whatever's in here. I mean, you never really can tell what's coming through. It's always something.
Job shop for you.
Job shop for you. Yeah, we do a lot. I mean, the steady flow stuff is a lot of crane wheels, a lot of gearboxes, brake assemblies.
Look at this press you have over here.
Yeah, that's our 600-ton press.
600-ton horizontal press.
If it doesn't push it, we don't need it, man.
If you're pushing 600 tons, I'm gonna be outside the building.
Yeah, it creaks and moans. It gets a little scary. You take a step back.
It does have a cool old Carlton rate alarm drill right here that we saw going by.
In the midst of all this clutter, we've got this is kind of the newest adventure we're going on.
This setup here.
This setup here, this was our go-to. This GMC was our go-to lathe.
Okay.
Since we got the American, we took it out of service from machining and basically turned it into a giant weld positioner.
Wow.
So what we're doing with it is, with all this,
got the gearbox up here.
Yeah,
for turning the spindle.
We turned it from we basically isolated all the functions and made it a complete CNC operated machine, and we retrofitted the Power Wave 1000 Lincoln sub-arc setup to overlay drive rolls.
Okay.
So we're working it out right now. It's not running yet, but we're days away from getting this thing working. We purchased this furnace, which will bring our rolls up to a 600 to 700 degree working temperature. We'll cart them out, grab them with the crane, fly it over to the lathe, chuck it up, and basically let the machine do its magic. We have to build these rolls up anywhere from 2 to 3 layers of continuous stainless hard face overlay, which is depending on the OD of the roll, anywhere from 400 to 600 pounds of wire.
Wow.
Per roll.
That's a lot of wear.
It's a lot of wear.
And that's really what you're doing. You're just building up the OD back to spec.
Back to spec. And then we'll take it over there to the American and turn it back down and ship it out.
Okay.
Yeah, we hope to get this going here shortly. But I'm pretty excited about this. We've worked pretty closely with Lincoln. They've been super helping us out with information and training and basically educating us on the sub-arc process, which is not familiar to me or wasn't. I mean, I'm still I'm still pretty rusty with the whole idea of it, but we're gonna get there. We're gonna figure this out.
I'm sure you will.
We can make it work, I'm sure.
Whenever you get this going, man, I want to see an Instagram video of the process.
We'll definitely document this whole thing. But yeah, depending on how many layers, if it's 3 layers with the finish size, it's gonna be about 24 hours of nonstop sub-arc welding.
Oh wow.
Per roll.
Yeah.
Yeah, each pass is about 8 hours.
Is that a solid shaft there?
Mm-hmm.
Okay.
Yeah, and that's actually small. Well, the one that's on the cart in the furnace is the size of the drive rolls that we will be working on. This was just a sample. I think this is a 16, if I'm not mistaken. That one there is an 18.
Now, will you guys, when you get them in, will you go ahead and machine them down, undercut them, or you just weld right over the?
No, we'll clean them up.
Clean them up like this.
Before we even start, this is what we'll start with.
Okay.
And then have at it, do our thing, and then once it gets built up, I think we'll try to shoot for about 330 seconds per side over.
Okay.
So we have a really good surface to cut back down. But yeah, Matt, the gentleman that's running the Zare over there, he did all this. He figured everything out, how to make this whole thing CNC and isolate the controls, but through the computer, bring them all back together and make it all work as one. So
that is a sweet setup.
Yeah, it's
specifically built for an application that you have. So,
right.
And you were saying that the mill has like 600 of these. So this is a continuing job.
Yeah, I mean,
I guess you could get as many as you want. Just keep them coming in.
I mean, this right now, I kind of look at this like a big prototype.
Right.
Once we dial this in and prove the system, we hope to do some more of this. Have several stations with this type of setup.
Yeah.
This is the rebuild end of things.
All right.
This is where the wrenches fly. This is where we put everything that's almost ready to go together and back out. So lots of, I mean, right now this is a big oven door that we completely rebuilt. All these little pockets have a spring-loaded plunger. So all these were removed, cleaned, rebuilt, new parts. Big refractory plug that goes in and insulates everything. And we do drive rolls all the time. These big disc rolls. That's basically where when the slabs are made, they roll out onto a table. That's what catches them.
Okay.
They do it that way to kind of help the slag drop and help the heat disperse, versus a solid roll like what was up in the lathe over there.
Okay. I'm just going to get a little closer shot.
With these, we just replace the discs. We cut the discs off.
You just weld some new rings on there.
Yeah, we'll take that roll, like say that's a bad roll, like these ones, for example, the ones that are ate up over here.
Right,
we'll take those, put them in the American, and that thing just eats them like it's not, just takes it right down to the shaft.
Yeah.
Then we'll fit new discs on it, weld them out.
Do you know what metal removal they're doing on the American to turn those off? You know what kind of depth of cut, feed rate?
I think if I remember right, they take quarter a pass off.
Okay.
And that's not even, it's not even breaking the sweat. I
No.
mean, it just flies through it. Like I said, the chips that come off, man, you don't want them anywhere near you.
No,
man.
no.
They'll go right through you.
I love this kind of work, man. You know, I miss working on the big heavy stuff. Crane wheel
Yep.
operation over here.
We do lots and lots of crane wheels. This is the area where they get rebuilt, measured, and sent back out.
Now you're talking overhead cranes?
Mm-hmm. Right here's one right here.
The big dake press.
This guy here, this is an idler.
Okay.
But yeah, these are all overhead crane wheels that we rebuild every day.
Dave just finished giving us the grand tour of the whole shop here.
That's it. That's all you get.
A lot of good stuff here, a lot of big boy machining and repair work, but I came to help him with the Eutectic Pterodyne system, so I think we're gonna go see about getting it set up and do a test spray with it and
Try to see what happens.
See if we can show them how I use it anyway. So we actually have Troy with us today. He is a Eutectic rep for this area. He's the one that sold the equipment to Dave. So he wanted to come by and hang out with us, kind of see what's going on right here. So Dave actually did purchase the entire kit that he needed, the Pterodyne 2000. We've been over here setting it up and we're getting ready to go. So I was gonna bring you in here, kind of show you where we're at. We are using this lathe here as the prototrack, but he's got one of his machinists that's gonna actually come over here and do the undercutting and the threading that we need to do for our sample, which is this guy here. It's a piece of, I believe this is a piece of 4140 that we're gonna just do a test cut on, is all. Here is the brand new Pterodyne torch right there. Got it all set up. We got our heat shields on there and we've got everything regulated and we're ready to do our demo. So this is Jeff. He is the machinist that's going to help us get this part turned and undercut. And we are, again, we're running the prototrack lathe here. So this is really interesting because this is something I have a lot of interest in. I'm watching him run the controls over here. He's got the undercut done, just getting it set up for the threading tool now. We'll make our one pass across it with the threading tool, and then we'll be ready to start doing some spraying.
That's one of the cool things. This will be tracking. So
that's pretty cool. I mean, you just crank that in, I mean, and it went in and just started cutting. So it's keeping track of the depth in. Once you get the depth, it just rolls. So when it gets to the end, will it kick it out and stop?
Yeah, and then you, since I have it in tracking, you just crank the handle, go back.
Oh, okay, there it shot it out.
And then back to the beginning, and then it'll take back off.
Okay. Very cool. We're just set up. We're getting ready to do the demo. One of the things that I noticed is I have to be really careful not to torch the control system right here. On my manual lathes, this is not sitting right here, so just got to be real careful I don't damage their lathe. And not just me, all the guys watching that are going to be doing this after me, because they're watching and they're gonna start doing this after I leave. 35, 75. I forgot I'm gonna have to turn it on and off. I didn't think about that, so I think that's gonna end up being in our way. I'll be careful not to hit it. Want to do a preheat on it, get it up to about 200 degrees. Pretty big shaft, so it'll take a little bit to get it up there. All right, we're preheated, so we're ready to go. I'm gonna put the T-valve on 5. And we'll bring it down. You want to stay 6 to 8 inches away from your workpiece. And we're not flowing. There it is. This valve here?
That's the on-off.
On-off. I'm going to go hit
5 for the first.
5 for your bond. I call it bond.
And 10 for the.
And then 10 for your buildup. Yep. Alright, so we got the T-valve on 5, and we'll go ahead and start it. Doesn't look very pretty to me. We'll go ahead with our build up and see how we do. That's looking better. Are you seeing how I'm doing that?
I am. It's kind of weird, like cutting or welding, you're seeing something happen on the surface. You're not really seeing a whole lot go on. I mean,
Yeah.
There's no puddle, there's no cut, nothing to follow.
There's you a better look at it right there. And then I'm gonna just don't let me burn you here. We're already about 25 thou buildup on that. You want to make sure that you have slow, smooth control over the torch here. You don't want to, it's not like a paint gun. Pretty close. We still got a little ways to go though. We're gonna go a little more. I hate that your center's right there, but that's how our setup already was. So. Pretty close. Let's make one more pass on it. We'll make one more pass across there and we should be pretty good. I think we're there.
That's it.
That's it. You get done, just shut the valve off like that, and then you go ahead and, you know, close everything out. And when you are done, don't forget to shut the bottles off. That's just my habit. I shut the bottles off so I don't leave them on. We've let our shaft cool down, so we're going to go ahead and Jeff's going to give us a hand. He's going to see if we can get this turned. We'll see how our buildup comes out. All right, so far so good. It's looking like it's doing a good job. What the cool thing to me is watching him run this ProtoTrack lathe here. It's because this is a whole different world for me, but it's been interesting how you operate this. You can control it here. So anyway, that's doing pretty good. We're just going to turn it down until we get it cleaned up, looking good. All right, guys, there's our sample finished up. We weren't shooting for any type of size in particular. I know it's just over 4 inches, but our buildup looks great. You can see our corners there. Intersects look beautiful. You don't have a gap in there. The finish is nice. We swapped out our tool for a 431 insert, brand new, and did a 5 thou finish pass on it. And the ProtoTrack lathe did a good job too. It's pretty cool. So I think our test sample here is finished up. Well, our visit here at the shop is just about over with. What'd you think of the system here?
Well, I'm impressed. I mean, I've never seen anything like it before. I'm definitely new to this whole spray weld thing. I'm kind of a caveman when it comes to welding. I like it the old-fashioned way, but as you can see, it's impressive, really. You know, this is the parent material. You can kind of see the turned stripes left and right, and this is all
the build-up
from the spray welder. There's literally zero transition, physical transition. You can certainly see the color change, but it's really remarkable. So I definitely see a lot of future application for this, for what we do around here, when we have a lot of bearing housing repair, shaft repair, stuff like that. So,
well, that's really cool, man. You know, you guys can maybe do a little bit more practicing with it. You know, set up. I know you got a piece over there that you're wanting to try.
Yeah, an
So-
OD or an ID rather.
Right.
Yeah.
Well, hopefully it works out for you. I think it's a good, solid system. It's always worked really well for me, and hopefully it's going to work well for you guys as well. The main thing is to, you know, the application itself of your undercuts, your preps, and applying it correctly. If you
Right.
do all those right, then you shouldn't have any problems with it.
I think you're right. I think, you know, follow the steps and you'll be all right.
Yep.
Plus, having a good instructor sure as hell helped too.
It just so happened that I've used this for a little while, and he was like,
Couple minutes.
do you mind coming up here and showing me how to use this? I'm like, we're actually driving by.
It just so happens.
Just so happened I'm driving by. Here's another little shot at the equipment, the Teradyne 2000 with the heat shields on there. The nice aluminum hopper, and the 21022 is the material that we use, just like I use at my shop. So that's about it, man.
All right.
I think I'm gonna head out. We're gonna head back to the camp, but we really enjoyed our visit here at Mill Mechanical.
Yes, sir.
Thanks, man.
Come anytime.